be a nice, easy lesson for you today. Quadratic formula. We've been using it all year, and it's used to find the roots or the solutions to quadratic equations when they can't be factored. Difference today is now you're going to see that we can come up with complex or imaginary roots, and that'll come from seeing a negative under the radical, which is what we talked about in the last few lessons. So without any further ado, we will get started. All right, so we got our A, B, and C. A is 1, B is -2, and C is 10. Now, I'm not going to list this out for every problem. You guys need to know that by now, right? A is the number of x squared, B is the coefficient of x, and C is the constant. All right, so we have x equals -b, that's 2, plus minus, so b squared, I'm just going to square that. I know that, I like to do this in my head. I know that anything positive or negative squared is always positive, so I just take that b value, 2. Doesn't matter if it's 2 or -2. It's going to be 4 when I square it. Minus 4 AC, 1 times 10, all over 2a. 2 times 1 is 2. 2 plus minus. Now look, 4 minus 40. 4 minus 40 is -36 over 2. And there's that negative under the radical. We've never seen that before. This is the first time you will have seen that because we have a radical, or we have imaginary roots. 2 plus minus, that's going to be 6i. Radical 36 is 6i. We already know that. Over 2. And then we could simplify by writing it as 2 over 2 plus minus 6i over 2. You could separate that just like addition. It's kind of like having a common denominator but going backwards, splitting up into two different fractions. And of course 2 over 2 is 1, and 6 over 2 is 3. So 1 plus minus 3i. 1 plus minus 3i. So we have two roots. 1 plus 3i, 1 minus 3i. This one here, we have a fraction here, so we're going to need a common denominator. So this is over 1 over 1. Now common denominator is 8. Multiply by 8, kind of squeezing that in here. Multiply by 8, multiply by 8, multiply by 8, multiply by 8. Here we don't need to because we already have the 8. Denominators cancel out. X squared plus 80 equals 16. Now we don't have an x term, but that's okay. X squared, subtract 16. X squared plus 64 equals 0. All right, so now my b value is 0. A is 1, B is 0, C is 64. X equals -b, so that's just 0, plus minus. B squared, 0, minus 4AC, all over 2a. 2 times 1 is 2. So that's 0 plus minus square root of 4 times 64, -256. We got the negative here. So -256 over 2. You know 0 plus anything is 0, so we really don't even need the 0 anymore. So we get plus minus square root of 256 is 16. But because there's a negative under the radical, we know there's an I there. So it's actually 16i over 2. And then 16 over 2 is 8 plus minus 8i. So I have two roots, 8i and -8i. If you want to write that as a solution, 8i, -8i. Okay? Two more. Common denominator again, this time 3x. So times x times x. I'm going fast here because this is review. You guys should know how to do this part. Common denominator 3x. Now here this is over 1, so you really should be multiplying by 3x here as well. But just to get that to cancel out. But again, 0 times 3x is just 0, so that doesn't really matter. 25x squared and then plus 9 equals 0. 0 times 3x is 0. Now a is 25, b again is 0, c is 9. X equals 0 plus minus 0 squared minus 4ac over 2a. 2 times 25 is 50. Alright, so we don't need the 0. Plus minus looks like negative 900. I did this ahead of time so we could save some time in the video. This is 900. So negative 900 over 50. So what's that come out to be? Well, that's 30i. Square root of 900 is 30, and then the negative under the radical we know is just I. Square root of negative 1, which is I. So that's going to be 30i over 50. And 30 over 50 is 3/5. So that's going to be plus minus 3i over 5. Or 3/5 I. 3i over 5 is the same thing as 3/5 I. And you could write it as 3i over 5 and negative 3i over 5. Or 3/5 I, negative 3/5 I. Last one. We got to do some work here. Find the roots. That just means set it equal to 0. The roots is when the g of x equals 0, so I just put that 0 over there. Distribute 4x squared minus 8x plus 15 equals 0. That worked out nice. ABC. X equals negative 8 is 8. Negative 8 squared is 64 minus 4ac over 2 times a, which is 8. 2 times 4. 8 plus minus 64 minus, you get negative 176 here. Negative 176 over 8. So that's going to be 8. This breaks down. I already did it, but you break down the 176. Here, let me just go to a fresh page here. So 176 would be, you could break it up however you want. 80, what would that be? 88 times 2, and then this is 44 times 2, and then 4 times 11, and then 2 times 2. So I have a pair of 2s, 4. 2 times 2 is 4. It was negative, right? So we have a negative 1 also. We have a negative 1 factor. So that's going to be I. All right, that's just kind of on the side there. So it's 4i radical 11. It's 8 plus minus 4i radical 11 over 8. And that's going to be 8 over 8 plus minus 4i radical 11 over 8. And that's going to be 1 plus minus I radical 11 over 2. 1 plus minus I radical 11 over 2. Because you got to write it in A plus BI form. 1 plus minus I radical 11 all over 2. So we have 1 plus I radical 11 over 2 and 1 minus I radical 11 over 2. Two different complex roots in this case. And we'll see you in class tomorrow for more practice on the quadratic formula. It'll lead us into lesson 34 where we're going to be using that to come up with determine the type of roots.